Hey, welcome to the last video of this topic, mass, volume, and density. In this video, we're going to start with volume. What is volume? Volume is defined as the amount of space an object occupies. Its unit are cubic meter, or written as m power 3. Volume is a scalar quantity, meaning that it doesn't depend or it doesn't have direction. We're going to learn how to calculate volume. We're going to start with volume of a regular object. So given a regular object like this, its volume is given by multiplying this side, and this side. So this side is called the length, this is called the breadth, and this is called the height. And volume is given by length, which is represented by L, multiplied by breadth, which is represented by B, multiplied by height, which is represented by H. So volume is equal to L times B times H. Given any other regular object, so long as you can measure its sides, you just have to multiply this side, and this side. For example, you can be given a cube. A cube has got this side, and this side the same. So what you have to do is just multiply this, and this. How do you get volume of an irregular solid? An irregular solid is a solid whose size cannot be measured using a meter rule. So there is a procedure not to get the volume of an irregular solid. The first step is to tie the irregular solid to a thin string. So tie a irregular solid. For example, if you have this rock here, so you want to find its volume. If you get a meter rule, you cannot measure its dimension because it keeps on changing. Here it is round, so it's difficult to get the length of this rock here. So what you do is you tie it to a thin string. The second step is put water in a measuring cylinder and record its volume as V1. So you get a measuring cylinder, you pour water in it, then you record the volume as V1. So the way to read the volume here, usually when you pour water in a measuring cylinder, it will appear like this. So you have a reading here and the reading here. So this reading here is not the one to get. You get the reading here. There's what we call there are errors when we're getting measurements. So when you want to get the reading here, you have to make sure that your angles are your eyes are at the right angle to this, which is called the bottom meniscus. So you make sure that your eyes are somewhere here, then you see exactly here. So look for this line which is horizontal here. The value is going to give you the volume, of course, depending on the markings here. So if this is 20, then this is going to be 20 centimeter cubed. So the point is, don't get the reading of here, get the reading of here. So with water poured in the measuring cylinder and with volume of this water recorded as V1, what you do is you go to step 3, where you gently insert the irregular solid into the measuring cylinder. So just insert it, and of course water will move up the measuring cylinder because the irregular solid has taken the space of water, and so we have water on top. And we're going to have a new volume which is called VF or V2, V final or final volume. So this is actually what is in step 4. Record the new volume of water as VF, which is final volume. So record that. Once this is done, you can get your volume as the volume of the regular solid then given by volume is equal to VF minus V initial. So you just subtract the final volume from the initial volume. That's the volume of your irregular solid. The last concept we're going to take a look at is density. What is density? Density is defined as mass per unit volume. The unit of density is kilogram per meter cubed or gram per centimeter cubed. So usually when you are finding density, if your mass is in kilogram, make sure that your volume is meter cubed. If your mass is in gram, make sure that your volume is centimeter cubed, because these are treated to be the SI units for density, kilogram per meter cubed or gram per centimeter cubed. And of course, density is a scalar quantity. Density is equal to mass over volume. So this is a formula. So if you want to find the density, just get the mass divided by volume. So this is simple. I won't go into examples. Well, whenever given a question, if you have been given the mass of an object and the volume, you can find density. If you have been given the density and the volume, you can use the formula again to find the mass, to make mass subject of the formula. So we're going to cruise into the last concept, which is called relative density. Relative density, which is defined as the ratio of the mass of the liquid to the mass of an equal volume of water. So the ratio is just the ratio of the mass of a liquid to the mass of an equal volume of water. So if they have asked you to find the relative density of this liquid, you just get its mass and then you divide it by the mass of an equal volume of water. What does it mean by an equal volume of water? So, by the way, all this can be written as a formula like this. Relative density is equal to mass of the liquid over mass of an equal volume of water. So, I need to do some calculations here, but let's see what it means, what this really means. So if you have been given a liquid and you have been asked to find the relative density, what you do is you just pour your liquid into the measuring cylinder. Let's say this is our liquid, so you record this volume for your liquid. Let's say oh, actually you don't have to record the volume, you record the mass. So you put your measuring cylinder on a scale so that you get the mass. So once you have the mass, let's say 10 grams, then again you get another measuring cylinder. If you have two, then again you pour an equal volume of water. So what it means is, if this is 10 centimeter cubed, 10 centimeter cubed, it means your water should also be 10 centimeter cubes. So that's what it means. 10 centimeter cubed, 10 centimeter cubed. That's what it means by an equal volume of water. This part of the definition, an equal volume of water. So if this is 10 centimeter cubed, make sure that this is also 10 centimeter cubed. So you record its mass, the mass of the liquid you are trying to find the relative density. Once you do that, you get this water again. You find its mass, which, for example, let's say it's 20 grams. So when you weigh this water, because they're different liquids, they're going to have different masses. So let's say you get 20 grams. So to get the relative density, what you do is you divide this 20 grams into 10 grams according to this formula. So you put mass of the liquid here and mass of an equal volume of water here, like so. So you're going to have 10 grams and 20 grams. When you divide, you're going to get 0.5. So this is your relative density. Another question can be added. What is the density of the liquid? So to get the density of the liquid from the relative density, what you do is you just add grams per centimeter cubed to the relative density. So the density of the liquid is 0.5 grams per centimeter cubed, while its relative density is just 0.5. This marks the end of this short topic. Hope you have enjoyed and hope you have learned a thing or two. For now, happy solving.